I'm going to tell you about quantum effect, which is a topic of engineering physics of BTech first year. I will explain this in you a easy manner so that you will be having a clear understanding about this topic. Start this. This quantum effect is given by H. Compton in 1923. I will tell you with the help of this figure. Uh, as you can see that there is a photon, X-ray photon, which is being incident on a substance, or you can say a electron, and then it is having a collision and it is scattered in two directions. So we will having its component also. So I am taking its x-axis as this and y-axis as this. Usually Compton has discovered that when a monochromatic, as you can see, there is a monochromatic beam which is coming, or which is of very high frequency. This X-ray is scattered by a substance or stationary electron. Then the scattered radiation contains two components, one having lower frequency and the other one is having the greater frequency. So that lower frequency or greater wavelength is known as modified wavelength, and that the other one is known as unmodified wavelength. When a scattering of high energy photon by a charged particle, that is electron, it results in an increase in wavelength between incident and scattered photon. Then it is called Compton effect, and you can also call it scattering, Compton effect or Compton scattering. In fact, there is still a photon after collision with electron, but its energy is less than that of the incident photon. It means only a part of energy is given to this electron and other one is gone there. So it is called incoherent scattering or modified wavelength. Before starting this, I am going to label it and its components in x and y axis. The angle between scattered, this is called a scattering angle. It is the angle between the direction of incident and scattered ray. It is the incident and this is the scattered ray. So this angle is called scattering angle, and the this is called direction of recoil of electron. You have also studied that there is now we will apply the law of momentum, and in this momentum you know that the momentum before collision is equal to momentum after collision. So and now I am going it mathematically. I have labeled this. So here you can see that this X-ray is coming, which is having this momentum as 0 because it is moving in a direction, and its energy is equal to mc square. We will be applying Newton's formula. And before scattering, this is the phenomena, this is the view, and after scattering, this is the view and its component. So this photon has this momentum as we are taking it as h mu dash upon c, and this energy as pc. Now and this is the x component and this is the y component, means this is the cos theta component and this is sin phi. So in cos phi it has been as h mu dash cos phi and p cos theta, and is this electron, this is that p sin theta. To apply that law of conservation of momentum first. According to law of conservation of momentum, momentum before collision is equal to after collision. So in x-axis I am applying that formula, which is h mu upon c and energy as 0 is equal to h mu dash upon c cos phi plus p cos theta. As you can see here, it is h mu upon c plus 0 and that is h mu dash upon c cos phi. So now I am applying this and p cos theta. Taking that it is in LHS and taking it as common, so it will like this, pc cos phi cos theta, sorry, this is our first equation. And now I am applying this in y axis. So in y axis you can see that it is 0 and here it is 0, but here it is h mu dash sin phi and p sin theta. I am not writing here h mu dash upon c sin phi, but it is here, and here you can see there is not anything. This is I will take 0, so I am taking at this 0 LHS, and after this sin phi p sin theta. So now I am bringing this here because it is minus, so it will be like plus. So and this c will come here. So when you will solve this, this will look like this. So now I have here, you can see our my second equation. Now I will solve this first and second equation. I will add this first equation, pc cos theta, and here pc sin theta. Add this and I will get p cos square theta. I am squaring that thing. Sin square theta is equal to, I am there, h mu minus h mu dash cos phi, and that's h mu dash sin phi. It will I am adding it by squaring it. You can do this by yourself also, and here you will get an equation. So when I will solve this, then at last I will get it as p h mu dash h mu dash square sin square phi plus h square p square plus h square mu square dash cos phi cos square phi, and then minus 2h square. I am opening that formula, that identity, and this is the equation. And after when I will solve this, then I will get a more simplified form of this, which is h square this h mu square plus h square mu dash square and minus 2h square mu dash cos phi. This is my last third equation of after solving this first equation and this second equation. I will guess this third equation. Going to apply the second law, which is law of conservation of energy. So as you, there is a formula in physics which is total energy is equal to kinetic energy plus rest mass energy. Then in rest mass we denote m as m naught. Okay, remember this. So now I am applying that formula. So here A is equal to k plus m naught c square. I am rubbing this, and now I am squaring this, so it will be like A square is equal to k square, k plus m naught c square whole square. So here E is the relativistic mass energy. Okay, so here it is the formula of energy. There E is equal to p square, E square is equal to p square c square plus m naught square c power 4. This is the formula, and so I am putting the value of this E in this equation. So now I will get it as p square c square plus m naught square c power 4 is equal to k square plus m naught 4. Get this in this equation E, so it will look like this: c power 4 then 2k m naught c square. So now when you will cut this, it will be cut in, it will got cancel out. Then p square c square is equal to k square plus 2k m naught c square. Now we also know that gain in kinetic energy is equal to is equal to h mu minus h mu dash. So we will by putting this, we will get p square c square is equal to putting this in this equation, then h mu minus h mu dash whole square plus 2k. I'm putting also the value of k here also, h mu dash m naught c square. This is my equation number 4. So now by equation 3 and 4, which by equation 4 and equation which I have got by solving that previous one, which was the law of conservation of momentum. So I have got this third equation and this is fourth equation, and after solving both the equations, I will get it as h square mu square plus h square b mu dash minus 2h square mu dash cos phi is h mu minus h mu dash square plus 2 m naught c square h mu minus h mu dash. So I will solve this, then I will get it as in a simplified form, which is this is equal to minus h square mu dash plus m naught ch mu minus mu. So I'm taking it common. It will look like this. Solving this here. So I'm you know that we can write mu as c is equal to mu lambda. So I will take mu as c upon lambda. Okay, so here I'm going to do this h c upon dash c upon lambda dash 1 minus cos phi is equal to m naught c square c upon lambda minus c upon lambda dash. You can see I am putting only the value of mu here in this equation. So I will get this equation. Now I am taking it common. Lambda dash 1 minus cos phi is equal to m naught c square 1 upon lambda minus 1 upon lambda dash. So this is the equation. Now I will solve it further. This h upon lambda dash 1 minus cos phi is equal to m naught c square, and I am solving this equation. Then I will get lambda dash minus lambda upon lambda dash. So after solving this equation, I will get it as lambda dash minus lambda is equal to h upon m naught c square 1 minus cos phi. So you can see that I have got this, and this is a change in the wavelength. So I can write it as lambda dash is equal to h upon m naught c 1 minus cos phi. So this is the final equation of Compton effect, which I have got by solving these two equations of law of conservation of momentum and law of conservation of energy. How simple is this? You only have to know where to apply the formula and in which component it is divided. For watching the video.